Welcome back to Maths with Arjun channel. In the previous video, we have covered till question number 7 of exercise 1.1 of rational numbers. Now in this video, we will cover the further questions of the exercise as well as take the concept further. So without any wasting time, let's jump into the video. So the question 8 says, is 8 by 9 the multiplicative inverse of the mixed fraction is given as minus of 1 by 8. So first of all, we have to solve minus 1 by 8 and then check is it the multiplicative inverse of 8 by 9. So minus of minus 1 by 8 comes out to be equal to minus of 9 by 8. And we know that the multiplicative inverse of a number is the number which when multiplied with a number gives the result as 1. So the multiplicative inverse of minus 9 by 8 will be the reciprocal of minus 9 by 8, which is minus of 8 by 9, and which is clearly we can see not equal to 8 by 9. Now next question number 9 says, is 0.3 multiplicative inverse of mixed fraction 3 of 1 by 3. So let's solve it. So 3 of 1 by 3 comes out to be equal to 10 by 3 and 0.3 is equal to 3 by 10. That is converting decimal to fraction 3 by 10. So the multiplicative inverse of 10 by 3 will be its reciprocal, which is equal to 3 by 10. And 0.3 is again equal to 3 by 10. Both are equal. So yes, we can say 0.3 is the multiplicative inverse of 3 whole 1 by 3. Now next question is, tell us the number that does not have any reciprocal. So let us consider the number 0 and take the reciprocal. So 0 can be represented as 0 by 1 and reciprocal of 0 is 1 by 0, which I have already cleared in the before videos, is equal to not defined. That is, it is not any type of number. So 0 has no reciprocal. Next sum says, tell the rational numbers which are equal to their reciprocals. So let us consider two rational numbers 1 and minus 1 and see if these are the numbers that are equal to their reciprocals. So reciprocal of 1 is 1 and reciprocal of minus 1 is minus 1. So 1 and minus 1 have equal to their reciprocals. Now next part says, which is a rational number equal to its negative. We can clearly say that 0 has equal negative, that 0 is number equal to its negative. This is the same question we have discussed before. 0 has dash reciprocals. 0 have no reciprocal. As reciprocal of 0 is not defined, which is not any kind of number. Now this is same question which is repeated again. The number dash and dash has own reciprocals or equal to their reciprocals. So I have discussed before 1 and minus 1 has their own reciprocals. Now next question says, what is the reciprocal of minus 5? So the reciprocal of a number is that number which when multiplied with the number gives the result as 1. So reciprocal of minus 5 is equal to minus of 1 by 5. Now next question says reciprocal of 1 by x, where x is not equal to 0 is. So reciprocal of 1 by x is equal to x by 1, which is equal to the number x. It says product of two rational number is always a dash. So product of two rational numbers is always a rational number, which we can clearly tell using the property A into B equal to B into A. That is using the closure property. So the next question says reciprocal of a positive rational number is dash. So reciprocal of any positive number, whether it's a rational number, integer, natural number or a whole number, would be positive type of rational number or that type of number. Now taking the concept further, next is the concept of finding rational numbers between two rational numbers. Now let us start by taking a simple example, and further we will be solving further tough problems also. So first of all, we have to find rational number between 3 by 10 and 7 by 10, which I will try to explain using the number line. So on the number line, we will represent the numbers as 0, 1 by 10, 2 by 10, 3 by 10, so on up to 7 by 10. So we can clearly see that the numbers between 3 by 10 and 7 by 10 are 4 by 10, 5 by 10 and 6 by 10. Also, we can represent 3 by 10 and 7 by 10 as 30 by 100 and 70 by 100. Simply we have done nothing but just multiplied the numerator and the denominator by 10 on 3 by 10 and 7 by 10, which does not make any change to the number. As on cutting the zeros, the result would be same as 3 by 10 and 7 by 10. Now there would be many numbers between 3 by 100, 30 by 100 and 70 by 100, and we can take any of these numbers as asked in the question. This same technique we are going to use while solving the problems, and one more technique that can be used while solving the problems, that is rational numbers between two rational numbers. Now the question says find 10 rational numbers between minus 5 by 6 and 5 by 8. Now here we will be taking the LCM. Though the LCM of 6 and 8 comes out to be equal to 24. On taking the LCM as 24 and multiplying the numerator and denominator with the respective numbers so that the denominator becomes equal and equal to 24, the results comes out to be LCM of 6 and 8 comes out to be 24. That is, the rational numbers comes out to be minus 20 by 24 and 15 by 24. Now we can select any 10 rational numbers between minus 20 by 24 and 15 by 24 from the range minus of 19 by 24 to the range 14 by 24. Now let us discuss another technique of finding a rational number between two rational numbers, that is using the mean technique. So the question says find a rational number between 1 by 4 and 1 by 2. Generally we use these techniques for finding the rational numbers up to 5, not more than that, between two rational numbers. But we can use for finding more than 5, maybe 10 or 20 rational numbers between two rational numbers, but that becomes difficult. Now coming to the question, find a rational number between 1 by 4 and 1 by 2. So first of all we will have to take the mean, and mean means adding the numbers and dividing it by the total number of numbers given. So the total number of numbers given is 2, so we are going to divide the sum of the numbers divided by the total number of numbers given, that is divided by 2. On solving this we get the number 3 by 8. So the mean would be in between 1 by 4 and 1 by 2. So we can clearly say that 3 by 8 lies between the rational numbers 1 by 4 and rational number 1 by 2. Now we are going to discuss the exercise questions, that is exercise 1 by 2 of the rational numbers. So the first question says represent the number on the number line. First number is 7 by 4. So 7 by 4 can be represented by dividing the number line in the form of the denominator as 4. So we will be making the number line in the form 0, 1 by 4, 2 by 4, 3 by 4, 4 by 4, 5 by 4, 6 by 4 and finally 7 by 4 is represented on the number line. Similarly, next question says represent the number minus 5 by 6. It will be on the left hand side of the 0 on the number line as it is a negative number. So similarly, as we have done for 7 by 4, we will be doing for minus 5 by 6. So we will be making the denominator as 6 and dividing the number line in the same way like minus 1 by 6, minus 2 by 6, minus 3 by 6, minus 4 by 6 and finally we come to minus 5 by 6. Next question says find 5 rational numbers smaller than 2. We can find any 5 rational numbers smaller than 2, but for the sake of convenience and simplicity, the 5 rational numbers smaller than 2 would be minus 3, minus 2, minus 1, 0 and finally 1. Now next question says find 10 rational numbers between minus 2 by 5 and 1 by 2. Now we can make the base that is the denominator such that there can be minimum 10 rational numbers between that. So we know that the number 50 comes in both the table of 5 as well as the 2. So we make the denominator as 50 by multiplying 5 multiplied by 10 and numerator with minus 2 multiplied by 10, that is comes to be minus 20 by 50, and 1 by 2 with denominator multiplied by 2 into 25 and 1 into 25, which comes out to be equal to 25 by 50. Now we can take any 10 rational numbers between minus 20 by 50 and 25 by 50. This method is more easy and less lengthy to solve rather than using the mean method. We can use any of the 3 methods, whichever is more convenient depending on the base of the numbers. That is, we can use the LCM method as well as the mean method as well as the method which I have used in solving this question, that is question number 4. Now next sum says find 5 rational numbers between 1 by 4 and 1 by 2. Now similarly we know that the number 40 comes in both the table of 4 as well as the table of 2. Now solving 1 by 4 as 1 by 4 multiplying 10 and in the numerator and denominator as 4 into 10 and 1 into 10, we get the result as 10 by 40. Similarly, we are going to multiply numerator and denominator by 20 to make the denominator as 2 into 20 equal to 40 and 1 into 20 equal to 20. Now we can take any 5 rational numbers between 10 by 40 and 20 by 40. Now next question says find 5 rational numbers greater than minus 2. So for the sake of simplicity, we can take 5 rational numbers as minus 1, 0, 1, 2 and 3. Now next question says find 10 rational numbers between 3 by 5 and 3 by 4. Now similarly we are going to make the denominator as closest to which will be the multiple of 5 as well as comes in the table of 4. Now we can think of it as 100. So we are going to convert 3 by 5 such that the base, that is the denominator, becomes equal to 100. So 5 multiplied by 20 equal to 100, and 3 multiplied by 20 comes out to be equal to 60 by 100. Similarly, in case of 3 by 4, 4 multiplied by 25 comes out to be equal to 100, and 3 multiplied by 25 comes out to be equal to 75 by 100. So we can take any 10 rational numbers between 61 by 100 and 74 by 100. So with this question we complete exercise 2.2, and this comes to the end of the first chapter of the class 8 maths, that is rational number. If you have any doubt in any of the questions, you can tell me in the comment section anytime, and I will again help you in solving the question again and make your doubt clear. So thank you. I hope you have enjoyed and understood well the first chapter of class 8's maths, that is the rational numbers. If you like the videos and are able to understand, kindly like and share the video and subscribe the channel. So thank you, and we will be beginning the next chapter from tomorrow. So thank you.